Hey everyone, like Jared said, my name's Daniel Neal, senior in power engineering technology major. For my portion of this project, I'm going to be talking to you guys about the operational aspects of wind turbines, and the key topics I'm going to discuss are environment and location, maintenance and accessibility, the type of turbine, whether it be of the horizontal or the vertical design, wind power collaborations, and offshore wind power. The last one for offshore, our project primarily focuses on landside applications, although through our research, we thought that it was important to include some information for offshore wind power as well, given that it's a growing industry across the country, and we thought that to make our presentation more well-rounded for the viewers, that we should include some offshore wind power as well. So the first section I'm going to talk about is environmental considerations. The biggest one here in Maine and around New England is going to be cold weather impacts on the wind turbines, how it affects the turbine components and blade life in particular, safety hazards and equipment damage which can result from cold weather, and accessibility throughout the year. So continuing on that, ice buildup on the turbine blades can cause microcracking and eventually lead to premature failure of the turbine blades and could have them needing to be replaced prior to their 20 to 25 year lifespan. Snow ingress to the internal components, like if snow can get into the tower, into the nacelle, it can cause damage to the electrical systems. The cold weather itself can also affect electrical systems such as the generator windings. If the turbine's put in operation and has a cold start and the windings are loaded up too quickly in the cold weather, they can suffer from thermal shock. Oil viscosity can also play a big factor because in cold weather, if the viscosity is not at the correct levels, the oil is not able to properly lube up the gears and can cause catastrophic gear damage within seconds of operation. And overall, cold weather startups just aren't good for the turbines. Luckily, there are some solutions in place to mitigate the damages, and one of those solutions is to put heaters inside the tower and the nacelle of the turbine to keep the oil warmed up and pre-warm the electrical components and windings prior to starting up the turbine. This can save a lot of headaches down the road, although it all depends. It's up to the turbine company or the power company to see if they want to put the extra money into this. As we just recently saw down in Texas, they opted not to have those extra backups installed, and they kind of suffered the consequences when they did have cold weather and they had no way to heat the turbines and they got iced up, and basically they had to shut them all down. So to avoid that in cold weather climates, it's a good idea to put some of those heaters in and make sure the turbines can operate year round without any major impacts. So my next slide's on turbine maintenance. Turbine maintenance is extremely important to make sure the turbines remain up and operational for the most time that they can. Turbines, like I said, typically have a 20 to 25 year lifespan. So whenever they're not operating, they're not making power and they're not bringing in revenue. And turbines typically cut it close to paying themselves off by the end of their lifespan as is. So any downtime they have is just cutting into that margin. Turbine maintenance can be extremely difficult due to many of the key components being high off the ground, which can lead to dangerous situations for the workers, like the guy in this picture, wind turbine technician, who's climbing out on top of the nacelle of the turbine and to perform servicing. Now he has his harness on, but it's still a very dangerous situation if he were to fall, and who knows how long he'd be dangling there before they were able to safely get him back up. So a big thing is that in the wintertime, access to the turbines in general may not be feasible, but also access into spots like where this guy's standing may not be accessible because they could have a couple inches of ice on there, which would make it even more dangerous for him to step out. So during the wintertime, typically companies won't perform maintenance. And when we were talking with Bill Follett, he even told us that a lot of the ones here in Maine, if the turbine has any issues at all, they'll remotely shut it down and then revisit the turbine in the spring once all the snow's gone and warmer weather comes around, then they'll service it and get it back up online. This can be costly because if that happens at the beginning of the winter, that turbine may be sitting for 3-4 months before it's operational again, which is a lot of money for downtime. But at the end of the day, it's keeping employees safe, so the companies kind of weigh their odds on that one. The roads also must be maintained going into the wind farm or wind site. So if you can't get a vehicle down there, it's hard to get your workers in, let alone any equipment you may need to bring in, as in like parts or cranes to move parts around. So typically they're going to have to pay to get those roads graded in the spring after mud season and just make sure that they're passable year round minus the winter time for most sites. One key point I did want to touch on is that typical turbine maintenance is usually between 1 to 2 cents per kilowatt hour, which doesn't seem like that much until you add it up over the time frame of a year, and you're looking at $42,000 to $48,000 per year per turbine, where all the wind sites I've seen here in Maine have at least 10 turbines. So you start doing the math on big wind farms, and the maintenance cost really adds up. So, but making sure that your turbine's properly maintained can really help decrease downtime, makes the turbines more productive, and they generate more revenue, and it kind of offsets the maintenance costs. All right, so my next topic is the horizontal versus vertical designs. The picture I use on this slide is demonstrating a offshore wind power scenario, but the basics of this apply to both land and offshore. So basically, the biggest thing I got when I was talking to Matt Fowler about whether or not vertical turbines could eventually be as beneficial or competing with horizontals was that simply at this current point in time, the vertical design, the technology just simply isn't there to make them as effective, even though they do have a lot of advantages over the horizontal design, which I'll talk about in a minute. The future into the field of vertical design turbines is likely, and there's actually current research going on about that, but there hasn't been any big headway or any shocking discoveries as of yet, although they think in the future that technology will allow them to directly compete with the horizontals. The biggest difference between the horizontal type and the vertical type are basically the number of components. So your horizontal turbine is going to have a blade pitch system and a yaw system, which basically it face the turbine and the blades into the wind to harness the wind energy. And then you're going to have the gearbox and the generator, which are located up in the nacelle, which is a couple hundred feet off the ground. The vertical type turbine is just going to have the gearbox and the generator, which are going to be on ground level, and then your blades can harness wind from any direction, and due to the low center of gravity, it can have a bigger rotor, which can be a plus over the horizontal design. So basically, less components, less chances of failure, and less maintenance on it. But when it comes down to efficiency, which is what's used to determine what type of turbine is going to be used at a wind site, the horizontal turbine just can't be competed against. One of the biggest factors when you're looking to turbine efficiency is capacity factor, which plays the biggest role in the efficiency of a turbine, which ultimately determines the type to be used. And the capacity factor is basically the average power output of the turbine over maximum power output at any specific time during operation. And the most common numbers for a horizontal turbine are anywhere from 0.26 to 0.52 for capacity factor. My next section is wind power collaborations. And basically I'm going to talk about the potential to combine wind and solar sites and other uses for the land below them, because wind turbines take up a lot of space. They have to be spaced so far apart, and they cover a very large area. So if you can use the land below them to create more power, or like here in Maine, you have land below them that you can use for hunting, hiking, fishing, snowmobiling, four-wheeling. I've done many of those things around wind farms. But like out in western states where you have a lot of flat like farmland, farmers can still farm and grow crops below them. Or if it's in a place where no one's farming, why not put a solar farm in there and create more power out of the same area? And this has been done in many places already and has proven to be beneficial. And like this picture here, you'll see there's turbines in the background, and then in the same grassy field area, there's a giant solar farm sitting right there too. So the biggest factor that comes in, and I'll use Maine as an example, is a lot of our wind turbines are up on the hills and mountains to get them highest off the ground to get the most wind power out of them. And in that scenario, solar panels probably wouldn't be very beneficial to put in there because you'd have to clear a lot of woods to get rid of the tree cover, and you'd have to figure out and make sure they're facing the right direction on the hill so that they're not getting limited sunlight for a fraction of the day versus a farm like the one in the picture where they'll have sunlight pretty much all day long. So, but this topic was brought up by a student in the class last semester who'd asked if you could put solar farms below a wind turbine site, and you absolutely can. It's just you just have to take into consideration what the land's being used for and really where the farm's located, and just make sure that it's going to be feasible and worth the investment. So the last topic I'm going to talk about is offshore wind power. And basically, offshore wind can generate a lot of power, although it is a lot harder to access and maintain than the land sites, just because you can't simply drive up to it, hop out of your truck and work on it. You have to take a boat out, they have to ship parts out to the turbine, and then from there they have to get up on the turbine and try to crane parts off the boat. And the ocean's never the same scenario. You go to a wind site here in Maine, it's the same road, basically the same conditions. They only, for the most part, stability wise, out in the ocean, there could be no waves. It could be waves 12 feet tall. They don't know. So it just kind of adds a struggle as well as a safety aspect to working on them. And there's also a lot more project planning and permitting that goes into this. I know Jared talked about this a little bit. But it's a long process and it's kind of miserable from what Bill said. So even though there is a lot of benefits to having offshore wind power because there's great wind sources out there, it's just a lot more complicated than landside applications. So now I'm going to turn it over to Nick, who's going to talk to you guys about the decommissioning process of wind sites and get you guys up and familiar with that process. Thank you.